Hello everyone, welcome to week 8, engineering problem solving. I want to talk a little bit about the quiz, but before we do that I want to talk about your schedules that you turned in Excel. By the way, those were very nice, good job. Some of you have no Excel experience, so I was very impressed. Others have done it before and know the value of it, so either way, nice job. Looking at your schedules, I know that some of you are second year students that are picking this class up, so I understand that you're not in statics. And I bring statics up because it is a core course and it's sequential. So if you miss statics, you can't take strengths in the spring. So it's Et221. It's a great class. It studies the effects of forces on rigid bodies, and it goes through equilibrium, and it is probably one of the most important courses in the program. So if you're looking to finish this program, engineering technology, go to work in a couple years. There's great jobs out there right now. There's going to be less graduates, so there's going to be lots of opportunities, I think. But this is a course you need to pick up because it's a prerequisite for so many courses in the second year. You won't have this course, and then you won't have strengths in the spring to then go into the second year. So I know some of you are just doing this exploratory-like, and that's fine. This course, though, gets into some solid engineering, so yeah, it's a great course. So I want you to get it if you want to pursue this program, because if you don't have it, it keeps you out of a lot of second-year courses. And those second-year courses are only offered once a year, so it's a very sequential thing. If this is at all interesting to you on the engineering side, then you should be picking this course up. Statics ET221. I teach it. I'm also teaching GE115. I see some of you are in that, so that's great. And Sustainable Engineering, ET210. Sign up for them, and it should be fun as we can make it given the current situation. So, this online stuff it's not my strength. It's probably not your strength. Maybe it is your strength. You guys are doing really good. But this is not my strength. My strength is face-to-face and communicating with you in class. So hopefully we'll get back to that fairly soon, because this is not, online instruction is not what I signed up for, and I'm sure it's not what you were thinking you were going to get out of your college experience. But y'all are doing really good. Just hang in there. You're not communicating with me that much, which means I think you've got it. Some of you had some trouble in the Excel stuff, so I'm going to go over the next Excel lab. We're only going to have one more of those, and then we'll be moving on. But let's do the quiz first. Nice job on the quiz, by the way. Excellent job. This was it. Where is it? This guy right here. Right? So you can see that front right side, remember this is the front. We all did good. We didn't all name our views, and I know that's kind of a touchy thing, but we got to name those views so people know how we've drawn the thing, because in the future we can draw it from whatever angle we want, right? So we need to be telling people what the front view is. Anyway, this corner is removed. That's one of the key geometries. There's a slot here. That's another key geometry, and then the hole. And then this front surface, several of you tried to change that surface and not make it flat, but when you see that surface that looks like this all the way through, that's a flat surface from the front view, all flat. Now from the top, we do see this angle change here, right? But not from the front view. The front view, it's nice and flat. So I do have, there's Excel. Let's go to the solution. There we go. So here's the solution. Nice job. One of you did it. Beautiful job, but you can see that in the front view, that whole front surface is nice and flat. This is really good. We got the views named. We have enough dimensioning on the object to where I could build it, right? I know all of the geometry. I know the size of the slot, 6. I know the length of the slot, 16. I see this surface. This edge is located right here at 12, so I know where to chop it off at. And I know how far to come up to locate that surface. So this is just a great job. I believe this person has some experience, so that does help, but hidden lines are in for the top view, hidden lines in for the right side view. Excellent job. All right, let's do a little Excel lead-in. Let's see if I can go to it. Okay, good. So, great job on your Excel spreadsheets. A lot of you used, borders like you're supposed to. You put some shading in, some of you, so that's really good. Outstanding job. I don't know if I just like to see myself or whether you like to see me, but I kind of like it this way, so I'm going to do it this way just a little bit, and then we can go back and forth, because when I click in Excel, it disappears. So I think you all understand that you have alpha in one box. And if you want to do any calculating, you cannot have your numbers in with that alpha, right? Your numbers have to be somewhere else. On this next exercise, you're going to build a few more equations, and these are going to be a little trickier equations. So it's going to work with a little trigonometry. So if you've not had trigonometry, you might have to do a little research. I am going to keep it to right triangle trigonometry, but you're going to do 3 objects, okay? You're going to do a triangle, you're going to do a circle, and you're going to do a rectangle. Triangle, circle, rectangle, okay? And what you're going to do is you're going to find the area, you're going to find the perimeter, and that's it. Area and perimeter of your shapes. So I want you to actually draw the shapes in. So inside Excel, there is a little drawing package, just like in Word. It's called Shapes, and it's right there. So I'm in Insert, Shapes. So I want you to use, for the triangle, a right triangle. Okay? So you're going to give yourself a shape, and then you're going to give yourself numbers of the size of that shape. So I will put up a document for you to copy or produce the same kind of thing. But I want the area and the perimeter to be calculated from the information given on the object, okay? So, for example, if my triangle, and I'm going to scoot my triangle over a little bit, but let's say my triangle height was 30. Inches, okay? And I'm going to choose all those, and then here's the justifications right here. So I can justify them like that. Height is 30 inches. We'll say the length is 65 inches, right? So, a couple things I want you to do with the triangle, and I'm starting with the triangle because it's going to be the most difficult. Uh-oh, where'd my visualization go? I guess I lost it. We'll see if we can bring it back up here, because I like to be able to talk to you guys. All right, here it is. Here I am. So, I'm going to have you calculate the hypotenuse. So, if you've not done the hypotenuse before, you're going to need the Pythagorean theorem. So hopefully you have done this, but possibly you haven't, right? I mean, not everybody's had this mathematics yet, so I'm going to give it to you, Pythagorean theorem. So this is just an old exercise that we have going here, but I just need a little piece of paper area, right? So it is c² equals a² plus b². where A and B are the sides to the triangle, and C is this long hypotenuse, right? So if you know A and you know B, you can get C through the Pythagorean theorem. Now, notice there's square roots in there, so you're going to have to figure that out with the formulas. There's lots of formulas that you can use, but really you just have to learn what the right notation is to create a formula, okay? But I can see that mathematically, to get C, I would take the square root of A squared plus B squared. So hopefully we all know what squaring is, right? This would be A times A and B times B. Now, this notation, though, this is going to be challenging for you to figure out. You can do it in chunks if you'd like, okay? You can do it in small pieces. So that means to get this C value or hypotenuse, I'm actually just going to call it the C value. And I'm going to right justify that so it scoots over. And then I'm going to say right here is where my equation is going to go. So if you just start at it like with your calculator, we know we have to start with the equal sign, right? And we know we got to take this thing and we got to square it somehow. Now, on your calculator, it would be this caret above the 6, right? It would look something like that. So I'm just going to test that. And it looks like it did it. It squared the 30, right? So then if it's like, oh, okay, if that worked, I'm going to add some brackets. And I'm using my arrow keys to arrow around. So I'm going to say bracket that, and I'm going to add to it the other one that I'm going to square, right? This one, I'm going to bracket this. Just like your TI, you want to kind of bracket everything. Doesn't hurt anything, okay? So that should now take this first number and square it, and the second number, these two, right? Enter it. Boom, did good. So now I just have to take the square root of it. Now, I don't know the square root information, but I know that the whole thing needs to be square rooted, right? So the first thing I'm going to do is I'm going to bracket the whole thing. This is going to combine it all together, right? Then I'm going to take my mouse, oops, got a little extra bracket in there, or got a wrong bracket in there. There we go. So now I can see I have the whole thing bracketed, and now I just need to know what the square root information is. What do you think? And I do encourage you to guess. The software is going to help you, right? When you guess, it's going to like bring things up and you can choose things. So don't hesitate in guessing at some of these formulas. What if I typed in SQ? Right away it says, hey, look, there's square root. So I'm going to choose that by two-clicking it. And it did. It put in square root, and my brackets were already in. It's collecting that whole thing. Let's see what it does. Boom. Did it. Okay, so just work your way through these formulas. I want you to do this for the triangle, the rectangle, and a circle. And you're going to do the perimeter and the area, but like the triangle, you had to calculate that hypotenuse for the perimeter. Remember, the perimeter is like if you were going to put a fence around the area, how long would the fence need to be? So for a circle, it's circumference. Now, everyone know the circumference equation? Circumference is, so let's see, for a circle, we know the area is pi r squared, right? So what's the circumference? 2 pi r. Okay? And I think the rectangle you can all handle. So, all right, that is it's going to be your last Excel exercise. It kind of, you know, the engineering problem solving class is really designed just to give you some engineering problem solving skills in graphics and Excel. And really we're supposed to do Word and PowerPoint. I might do one of those. And then I want to talk about additive manufacturing too. So a little demo on SolidWorks and AutoCAD for the future. If you're taking GE115, that's AutoCAD. So I'll try and get the AutoCAD codes early so you can work on getting that downloaded before the start of winter term if you're taking that class. That's a software class, okay? All right, that's it. Good luck on Excel 2, and I'll talk to you on Wednesday.